All right, so let's put this all together. Oftentimes we have more than one transformation going on in a function. And so you can see, um, I've got a little bit of a method here for graphing a function where you've got a vertical stretch or compression going on, and you've got horizontal compression and horizontal shifts going on, right? So the B gives you a horizontal shift, the B gives you a horizontal stretch or compression, and the C gives you a horizontal shift. Okay, so there's a lot going on, and so sometimes it's hard to tell just by thinking through how much you know about transformations. So there's a technique that kind of a process that you can go through to help you graph these kinds of functions when you've got multiple transformations going on. And the key is just to recognize how it's going to affect where the asymptotes are. So that bx minus c portion is what's causing all of the horizontal transformations, either stretches, compressions, and translations in the horizontal direction. And that's what's going to determine where the asymptotes are. Now, that bx minus c is the input to your tangent, right? And you know that if you put pi over 2 into tangent, that's where one of the asymptotes is going to occur. When you put negative pi over 2 into tangent, you get an asymptote. So we want to find out where those new asymptotes are, so we can look at this inequality where that bx minus c is between pi over 2 and minus pi over 2. Okay, we're looking for the values of two consecutive asymptotes. All right, and if you solve that inequality for x, you'll identify where those new asymptotes are. Then once you've got those asymptotes identified, you know that right in the middle between the two is going to pass through 0. Okay, and then on either side of 0 are where it would normally go through 1 and minus 1, right? A quarter of the way and 3/4 of the way between the asymptotes. It would normally go between 1 and minus 1, but then we're multiplying by a, so it's actually going to go between minus a and positive a. Okay, so let's go through this process here. I think it'll make more sense when you see it in action. So in example 5, we're given a function where we've got a number of different transformations. We've got 1/2 tangent of 2 theta minus 7 pi over 2. All right, there's a lot going on there. We want to graph this thing. So what I'm going to do is first of all look at that the input to my tangent function, that bx minus c, and I'm going to solve this inequality for x, which will tell me where my asymptotes are. Okay, so I'm going to take this 2 theta minus 7 pi over 2, and I want to solve this inequality. So I want to find the theta values that are between pi over 2 and minus pi over 2. Okay, that's where my asymptotes normally are. And that's the input to the tangent function. So what am I going to do? I'm going to add 7 pi over 2 to both sides. Or to all sides, I guess. Well, actually, what I think I'll do is split it up into 2 inequalities, because this is really 2 inequalities in one. So I have, here on the left side, I've got minus pi over 2 is less than 2 theta minus 7 pi over 2. Okay, I'm just kind of splitting it down the middle. And then the other inequality I have is 2 theta minus 7 pi over 2 is less than pi over 2. Okay, and then we'll just work with those inequalities separately. I think it'll be easier. So I'm first of all going to add 7 pi over 2 to both sides. Okay, that just moves that 7 pi over 2 to the other side. So 7 pi over 2 minus pi over 2 is 3 pi over 2, or sorry, 6 pi over 2, which is 3 pi. So we get 3 pi is less than 2 theta. And then, so that says that 3 pi over 2, just dividing both sides by 2, is less than theta, which can also be read that theta is greater than 3 pi over 2. Okay, so theta is greater than 3 pi over 2. That's where one of our asymptotes is going to be. So essentially that minus pi over 2 asymptote gets translated over to 3 pi over 2. All right, now let's find the other asymptote. We're just going to do the same thing using this other inequality. We're going to add 7 pi over 2 to both sides, right? Plus 7 pi over 2. So this will go away. I get 2 theta is whoops, not equal, less than, okay, so I have pi over 2 plus 7 pi over 2, which is 8 pi over 2. 8 pi over 2 is just 4 pi. And then I want to divide both sides by 2, so I get theta is less than 2 pi. Okay? So I can put it back together now and get the theta is between pi over 2 and 3 pi over 2. 3 pi over 2. Okay, so my new asymptotes are at 3 pi over 2 and pi over 2. So what does that mean for the period? I can get the period just by looking at the difference between the two asymptotes, right? The difference between the two asymptotes gives me the period. And so, so the period will just be equal to 2 pi minus 3 pi over 2, right? So that's 4 pi over 2 minus 3 pi over 2, which is now pi over 2. Which makes sense because we have this vertical compression, or sorry, horizontal compression going on, right? This means that there is a horizontal compression. But I tell you, I don't memorize all those translations. I'd rather reason it out. Okay, so there's my period. So let's draw in where those asymptotes are, at least the asymptotes that we just found, right? We have 3 pi over 2, which is going to be, so pi over 2, well, here's 3 pi over 2 right here, right? There's 3 pi over 2, and here's pi over 2. That's one period, right? So my normal negative pi over 2 to pi over 2 asymptotes got shifted over to 3 pi over 2 and 3 pi over 2 and 2 pi. Okay, so now what I can do is I know right in the middle it's going to be 0, right? Because I don't have any. You can see I don't have any vertical translation going on, right? So and then I do though have a vertical compression by a factor of 1/2. That's what this a value is telling me. I'm getting a compression by 1/2. So rather than passing, halfway between, the middle and the asymptotes, it's going to pass through 1/2 and minus 1/2 instead of 1 and minus 1. Okay, so one cycle of my tangent is going to look like this. It's going to look like that. Okay. And then I can just repeat it for whatever interval I'm interested in. So this problem is asking me to sketch the graph of the function between minus pi over 2 and positive pi over 2. So I know the period now is pi over 2, so I'm just going to put in more asymptotes at every pi over 2 intervals. So I'm just going to sketch in all those asymptotes. Now you can see there's going to be an asymptote right on top of the y-axis. All right, and then I'm just going to sketch in all of my asymptotes. All right, and there'll be one here at minus 2 pi. All right, so there's my asymptotes, and then it's just a matter of then filling in all these cycles. So I get a 0 right in the middle, plus and minus 1/2, and then I can sketch what it looks like as best as I can. Okay, so there's another cycle. All right, so I've sketched in all of my my cycles of this tangent function between minus pi over 2 and pi over 2. Now, I didn't answer the original question here in part A, which was to find all the vertical asymptotes between negative pi over 2 and pi over 2. Okay, but I've drawn them all in, so now I just need to label them, right? So I have one at 2 pi. Well, they're kind of already labeled because they go right through numbers that are already labeled, but I have them at pi over 2, 3 pi over 2, pi. I have pi over 2. I have 0. I have minus pi over 2. I have minus 3 pi over, oops, sorry, not 3 pi over 2. hang on. Let me go backwards here. Minus pi. This is minus 3 pi over 2. And this is minus 2 pi. Okay, so these are all values where x is constant. So it's x is equal to all of these values, minus pi over 2, minus 3 over pi over 2, and so on. Okay, so those are my asymptotes. So, all right, well, I think that's all for this video, and I'll meet you for the next one.